So we're going to start this session. Welcome to you all. Thank you once again for being with us. So we continue these webinar sessions. Before I explain a little bit about what we're going to describe today, probably we should introduce ourselves. So I have Joe White. You want to start, Joe?
Sure. Good morning, everybody, or good afternoon if you're in Asia. My name is Joe White. So I'm the business development manager for NEXO in Southeast Asia, Australia, and India. I've been in the position for just over a year now. And previously I was at NEXO doing marketing, but this is going back a long time. I see a lot of old names on there that I've met in the past. So good morning, everybody. Happy to see you all here and looking forward to this webinar.
Thank you, Joe. Nicolas.
Hello, gentlemen. Good morning, good afternoon. I don't know. Good evening. Maybe no. I don't know what time is it in your country. So I'm Nicolas from NEXO Engineering Support, and taking care of training session all over the world, and also involved in the webinar training session. Very pleased to welcome you, and please also to share the presentation with François to do this 2-hour training session about subwoofer.
All right, and I am François Desfarges. So I am head of engineering support at NEXO, and so yes, it's a pleasure to share this webinar with Nicolas and Joe today. A quick brief on how this session is going to be organized. Joe will be managing the chat as well as the question and answers sessions. You have an icon with question and answers. It's very nice if the questions you have, you put them in the question and answer session, not in the chat page. So the chat page is just to say hello and so on, and eventually exchange some private news. You can do that privately. But please, for the question and answers, as we're doing the presentations, use the question and answer section. That's the first point. Second point, so we're going to have this subwoofer session organized in 2 parts. The first part is about how directional low frequency is achieved. So it's about end-fire, cardioid principles, passive cardioid principle, active, etc. And this is, let's say, the sub itself, right? And then we'll take probably a short break, 5 or 10 minutes. And after that, Nicolas will take over. And Nicolas will discuss about, once we have an Omni or a cardioid subwoofer, how to arrange them, and what are the benefits and the drawbacks of arraying them horizontally, vertically, in stereo, in mono, etc., etc. So this is this webinar construction. And this being said, I believe I'm ready to start. I really want to, before I start, I really want to mention that this is a very difficult subject. And the reason why it's a very difficult subject is that first, low frequency radiation is almost impossible to properly model inside rooms. There are no simulation software that allow to properly model how low frequency is going to behave inside room acoustics. So that makes it kind of a little bit unpredictable. And so there is although we're going to put all the theory here during this session, we have to be extremely cautious always and keep some headroom for experimentation on site, always, as much as possible. All right, so let's start with a little bit of how to achieve low frequency directivity. It's a very quick review here. Back to that, for those who attended the fundamentals of acoustic session, you've seen that slide already. But we said in the session last week that when we talk about the size of an object, which can be an obstacle or it can be a speaker, yes, we always have to compare it to the wavelength, which means that, for example, a line array, which is 4 meters, cannot control low frequency. This is what we kept on saying. And that, for example, a point source is a source whose dimension is very, very small as opposed to the wavelength, and therefore is omnidirectional. So this is what we said last week. And now we're going to see that, in fact, this is not totally true. And that's for wavelength, which is extremely long, such as, 10 or more, up to 17 meters for 20 hertz, we can, in fact, do directivity. So we're going to look at why and how. So first, for the introduction of the Cardioid subwoofer came on the market around the years 2000, right? And there were some attempts in the past, but in our industry of live music, up to 2000, there were almost no directional subwoofer. So they were omnidirectional. And being omnidirectional, what are the drawbacks? Well, the drawbacks, we can look at it, and everybody knows about that, is that first, using omnidirectional subwoofers would lead to lots of sound, lots of low frequency on stage, eventually more low frequency on stage than there was in the audience. And as a consequence, in order to avoid feedback, we had to set high-pass microphones, on all the microphones we're using on stage. The two only ones that we would not high-pass, or the three, let's say, of course, everything which was line input, we would not high-pass, but this is not a microphone. But we had to high-pass, the singer microphone, etc. The only one who would probably not high-pass was the kick drum. But apart from that, it means that having low frequency on stage, in fact, forced us to damage the sound pickup in order to avoid feedback. Also, the problem we have in most of the venues we work in is that the reverberation time in the low frequency is much higher than in the mid and the high frequencies. So it means that in the low frequencies, we have omnidirectional sources in a very, very reverberant environment. So this, I'm sure that all of you who has been doing sound checks, experimented, the kick drum when you start the sound check that lasts for 5 seconds. And it's like, oh, wow, no, this is going to be difficult today. Anyway, so that's also, and this is because being omnidirectional, the subwoofers are exciting the entire venue. Also, I started mentioning that in the introduction, but you see, this is a flown subwoofer. It's just a theoretical model. And you can see, in fact, that sub is omnidirectional, and you can see how it affects how the pressure is being distributed in the room. And the distribution of pressure in the room depends on the subwoofer position, but also on the venue, on the room itself. So we can have extremely uneven coverage. And you can see just by, if that subwoofer was to go in a corner, the distribution would be totally different. I forgot, let me go back 2 slides. Also, having omnidirectional subwoofer lead eventually in a stereo mode to very heavy power Ailey effects, because we have 2 sources which are left and right at a large distance, and in fact they interfere one with the other. And the only position where actually both are in phase is the center. Okay, so interferences pattern with omnidirectional subwoofers are also extremely critical. And more, and this is very sensitive in Europe, but this is generally very sensitive when places are with very dense population. We have outdoor festivals, and these outdoor festivals can occur, in densely packed places. So you see, I have 2 subwoofers here, 2 LS18s, okay? And this is what they produce over my field for an open air show. And now, if I keep on going wrong with the arrow, but you see, this is the pollution, the sound pollution impact over the residences and the houses which are nearby. So that's also a problem, is generating too much low frequency in the neighborhood. So these are all the problems that directly derive from the fact that subwoofers are omnidirectional. So then the question is, how do we manage to get directional subwoofers, directional radiation with systems which are extremely small as opposed to wavelengths? And the answer is very simple. I'm sure all of you are experimented with microphones and cardioid microphones. This is a KM Shops 184 on the left, and to the right, I believe it's a U87 from Newman. And so there are two principles. One is passive cardioid, and the other one is active cardioid. Passive cardioid means, and we're going to convert that in the next slide, you see you have openings on the side of the microphones, and we're going to see why these openings are required. And for those of you who are familiar with an SM58, when you close these openings, you know, when you put your hand on the microphone, it becomes omnidirectional, and this is why it starts feeding back. The active principle in the case of the Newman U87, but this is also the case on the AKG C414, it's two capsules. And depending on how we recombine these two capsules or this dual membrane, we can achieve a wide variety of polar patterns. So passive cardioid principle. You see, I have my loudspeaker here, and my loudspeaker is radiating to the front, right? And the rear part of my transducer, of my loudspeaker, is out of phase with the front part, because when I'm generating a plus pressure at the front, I'm generating a negative pressure at the back, right? And if the path from the rear radiation to the front radiation is identical, that is, if, let me show here with the mouse, you can see my mouse, Nicolas?
Yep.
Yep. You see, if the length of the path here is the same than the blue one here, it means that the two signals at the back are going to arrive simultaneously and are going to therefore lead to a cancellation because the rear signal is out of phase with the front signal. So this is the passive, this is how microphones are made, and this is how passive speakers, cardioid speakers are made. The drawback here, of course, is that the efficiency of the radiation in the very low end is extremely poor. Okay, so yes, we have no low frequency at the back, but the efficiency at the front is strongly decreases. We have an example at NEXO, which is a legacy product in our catalog, but the downfield of the GOT, this is back from 2003, 2004. The back part of the 2815, the GOT 2815, which was the downfield of the GOT 4805, was passive cardioid, okay, with a resistor that is set at the back to control the level of attenuation we want to achieve. And these were the rear acoustic radiators. If we go active cardioid principles.
François, a question that's, so this is not a question that the people ask, but the question that I usually have during the seminar is it the only reasons you mentioned the efficiency in the front of a subwoofer with a passive cardioid principle? So is it the only reason why NEXO decided not to go through this kind of technology for cardio?
It's just that, Nicolas, on the product we've been developing since then, yes, there was no real requirement or application case for that. It is not to be excluded that, you know, we eventually use that principle again. But again, at the time, we have great expectations on low frequency efficiency, and the music is more and more demanding today. It's difficult to sacrifice efficiency for directionality. Yep. Okay. So that's the major drawback. But once again, Nicolas, we could imagine more sophisticated passive designs, you know, that eventually could lead to new products. So now we're going to look at active cardioid principle. And that slide is a bit misleading because you can see the term end fire and the term gradient. The cardioid, in fact, is the gradient, but we're also going to look at end fire. End fire is not exactly cardioid, but we're going to see what it does. End fire, imagine you have a subwoofer with a front driver and a rear driver, right? And what you do is you delay the rear the front driver, sorry, so that it comes at the front microphone simultaneously with the rear driver, right? And you can see here at the front, okay, I'm going to get, because I'm at the front, I'm going to have the two signals simultaneously over all frequencies. So I'm going to have a very nice plus 6 dB summing. See, that's the front speaker without the delay. And when I put the delay, I'm summing now on the front driver. I'm properly summing front and rear driver. And at the back, it depends on the frequencies. At some frequencies, it will sum. At some other frequencies, it will cancel. So you see, this is what you can see. At the front, we get a very nice plus 6 dB. And at the back, in fact, we get a comb frequency response of this type, comb filter type frequency response. So attenuation at the back will be frequency dependent. All right. So you can see here, okay, this is the response at the back. All right. And in the specific case where the distance is a quarter of the wavelength, only in that specific case, then we get cancellation at the back. All right. Okay. But at other frequencies, it's not going to be like this. So it provides a very good summation at the front, but the coverage pattern is inconsistent. We recommend to design so that the pattern is optimized at 63 Hertz. That gives more or less a distance of 1.35 meter, right? From the front, if I put two subwoofers, one behind the other, that gives more or less 1.35 meter. This is the value we recommend in case you want to go and fire. And you can see here directly the illustration of what I mentioned. You can see that I have a pattern in the low frequency at 50 Hertz, which is a little bit directional. At 63, I have a much stronger attenuation at the back. And at 80 Hertz, I have like an hypercardioid type, right? So I'm moving from omni to infracardio to cardio to hypercardio. And if I carry on, I'll go to bidirectional. But the reason why at NEXO we do not use and fire in the setups we do is because of the inconsistency of the coverage. Okay, so now we can look at same design, but we're going to do what is called a gradient subwoofer. So a gradient subwoofer, now you look at it very closely. What we're doing, we're delaying the rear driver, right? Sorry, we're reversing the phase of the rear driver and we're delaying it, all right? And by doing that, if I'm sitting here at the back, it means that S1 and S2 at the back will arrive simultaneously, right? And because they're out of phase, I will have perfect cancellation at the back, right? This is what we call, for microphones, it's called gradient microphones, or we call it gradient subwoofer, but this is the cardioid subwoofer principle. So now the question, of course, is what does occur at the front? Okay, and you can see, okay, so now this is no delay, this is with the delay applied, and this is with the phase reverse, right? And now at the back, as you can see, I have always minus infinite, right? But now at the front, what's going to occur? And this is the biggest difficulty in designing cardioid setup and cardioid subwoofers, is that when I'm sitting here, I will have the signal of the front driver, and then I will have the rear driver, which is delayed twice, because there is the physical delay now and the electronic delay, and then phase reverse. And of course, if I don't do the things properly, then it means that the question is 2 times the delay plus phase reverse. Is it going to be in phase again? Yes or no? And the biggest difficulty is to design actually the depth of the subwoofer and the proper setups so that we are in this range here where rear and front drivers actually sum up. Okay, theoretically, that range here can be up to almost 3 octaves, which is fine enough for a subwoofer. 3 octaves is, 25 Hertz all the way to 200, all right? In fact, it's a little bit less than that. But this is provided the depth of the subwoofer is properly designed, okay? And you see, this is what we have here. This is the usable range of the cardioid subwoofer. And now look at it. This is very interesting. You see, this is two subwoofers spaced 1.7 meter, one behind the other. And you can see that now, although I don't have as much efficiency as an end-fire at the front, maybe I have 1 or 2 dB less than an end-fire array, but I have consistent coverage at the back. And you can see whatever is the frequency now, 40, 50, 63, we have the same coverage pattern. Okay. Nicolas, Joe, so far so good?
Yeah, just a question regarding, the space. So when you discuss about the space between the two subs in the gradients case,
yes,
is it better to can we make a cardioid subs with a smaller distance compared to end-fire, or
very good question. If you make a small distance, yes, between two subs in cardioid mode, you will have cardioid efficiency maybe at 200 hertz or 300 hertz. And the deeper you go, if I go back to that usable range here, Nicolas, this is directly proportional to the depth of my cardioid system. The deeper is my cardioid system, the lower this will go. Okay. And the smaller is the distance, the higher this will go. But don't forget that here we lose efficiency also.
Yeah.
Okay. So, for example, if I take some examples at NEXO, the CD18, for example, if I remember well, was 1.2 meter, and we had a maximum cardioid efficiency somewhere around 50 hertz or something like this. Okay. So we define the depth of the system, yes, depending on where we want maximum efficiency in cardioid mode. Okay. So you can see here, okay, this plot here, okay, I hope you can read it. Okay, for a gradient subwoofer, you can see we achieve very nice cardioid pattern, and there's a frequency above which, and it's in fact half the wavelength for the separation between the subs, there's a distance above which we can no longer use the sub. So in fact, you see, this plot below shows the gain at the front when I'm connecting the rear driver, right? So I'm sitting at the front, the rear driver is muted, and I put it on. And by putting it on, you can see I have gain from that region to that region. And this is, in fact, I said 3 octaves just before. This is not true. In fact, it's 2.3 octaves. Okay. So this is, this is depending on the depth. The smaller the distance between front and rear, the higher this will go in frequency. And the larger the distance between the subwoofer, the lower this will go in frequency. Okay. The reality, what I've shown you are very basic theoretical principles. The reality is that it's not as simple as that, unfortunately. But when we measure, because what we care is not the physical distance, what we do care is the acoustic distance. And the acoustic distance is, I have my 2 speakers, one at the back, one at the front, and I make a phase measurement at the front, okay? And I make the phase response of the front part, the phase response of the real part, okay? Or the group delay, if you wish, of each, okay? And I subtract to see the actual difference. And in reality, the acoustic distance is going to vary with frequency. It is not constant, okay? So it's not a pure delay that we have to apply. We have to apply something which requires delay that varies with frequency. In order to do that, we could use FIR, but FIR are too much time consuming in terms of latency. So we use all-pass filters, okay, which minimize the group delay, okay, and that follow, in fact, the acoustic distance. The acoustic distance generally between front and rear is larger than the physical distance at low frequencies and is less than the physical distance when we go in the upper range, okay? So we typically use all-pass filters at NEXO to properly optimize the attenuation. So we have plus also to mention, this is not purely theoretical. We're not very much interested in having a pure attenuation minus infinite exactly at the back. What we're interested in is having an average attenuation at the back, which is good in the rear part of the radiation. So in reality, what we do, these phase measurements, we do over all the angles, all right? And then we adjust so that we maximize front radiation, okay, over 120 or 180 degrees, and we minimize the rear part by scanning frequency by frequency what is the exact difference in phase front to rear. Okay.
François?
Yes?
There was a question from Gabriel in Indonesia about efficiency. So I think from a speaker manufacturer standpoint of view, for doing cardioid subs, what does it mean for us to be efficient? Is it the number of drivers that we put into a subwoofer, or are we talking
efficient? Efficient, Joe and Gabriel, is simply that I don't think there's anyone on the market who will accept to pay for 2 drivers which are producing less than 1 at the front, right? So this doesn't make sense. Nobody's ready to pay such a price, right? Just for the benefit of directionality. So in reality, again, the very challenging part is to have rear and front properly summing. That's the difficult part. And we can go, as you can see here, this is a patent. So this is in fact maybe answering a little bit to your question. You see, this is an RS-18, and we have this patent at NEXO where we have a conventional subwoofer with the same signals being applied to the 2 drivers. And when we rotate that cabinet by 180 degrees, by 90 degrees, when we rotate that box, suddenly we have the ability with specific setups to apply different signal at the front and at the back, okay? And because the vents which radiate the lowest frequency are widely spaced, you see here, distance between vents, than the drivers, we have an object where the acoustic distance, okay, gets smaller as we increase in frequency, all right? And so you can see here, this is in fact the gain, theoretical gain that we get from that pattern. It means that we're capable to extend the frequency range over which we have directionality cardioid. And in fact, this is the measurement. See, this is a measurement of an RS-15, sorry. The blue is the front, rear is the back, and you can see this is the summation. So Joe, in average, to answer again, Gabriel's question, we managed to have 4 dB summation, 4 to 5 dB summation instead of 6. So the drawback as to Omni for the level we get at the front is 1 or 2 dB, not more than that. Okay.
Perfect. Thank you.
We don't see your mouse anymore on the screen, so I don't know if there is.
Sure. Sorry. Yeah. Okay.
Okay. Cool.
All right. All right. So a quick review of what we offer as a subwoofer at NEXO. Okay, we were among the very first, in fact, the very first, to my knowledge, that brought a cardioid subwoofer to the market, I believe was a Meyer Sound with a subwoofer which was called the PSW600, I think. It was 2 18s at the front and 2 15s at the back. Anyway, I'm not sure if that has been very successful. But anyway, we at NEXO, the very first product we came out with as a cardioid subwoofer was the CD12 to go together with the GOS8, and we also came with the CD18. Okay, these are legacy products, to go together with the GOT. So these were native cardioid subs, right? Extremely powerful. You could see very bandpass profiled. Anyway, so this at NEXO was in 2001 for the CD12 and 2003 for the CD18. All right. And after that, we carried on with GOT and GOD were also line arrays that were native cardioid. Okay, the RS, you can see the RS 18 or 15 coverage at all frequencies. And look at something, because I'm sure Nicolas will talk about it in the second part of our presentation today. But you can see that when we rotate the sub by 90 degrees, the lobe is going sideways. Okay, the lobe is not symmetrical to the subwoofer. The lobe is going sideways. And this has also, we will talk about it, a very great benefit. And then we have on STM, we decided not to go native cardioid because there are some cases where in fact it's not that required to be cardioid. If your subwoofers are on the proscenium just next to a wall, you might not want to be cardioid, you might want to be omnidirectional. So we decided with STM to give the ability to combine the subs with different signals. And you can see this is back to back. So this is 1.5 meter difference. This has extremely high efficiency in the very low end. However, 1.5 meter plus 50 centimeter at the front and 50 centimeter at the back means that you need lots of space, right? Front to back, okay? And here, when we go side by side, the efficiency tilts up in frequency, but we don't use that much space in depth. And we have a 45 degrees tilted radiation beam, right? So these are the setup we offer with STM. And on GOM for the M subs, right? We have Omni Assembly. The subs are perfectly symmetrical front to rear, and we can connect them frontwards or front and back. And you can see, and we can change the ratio from 1:1, 2:1, 3:1. The ratio at NEXO we recommend is somewhere 2:1, 3:1. Okay. And this is an illustration, for example, with LS18. We have M subs, we have LS18s, which can go cardioid, and we also have the IDS110, the IDS110, yes, subwoofer, which can go this way. All right. So if I summarize this first presentation, first part, rear radiation at the back can be lowered by more than 12 dB, which is good for the stage as well as for the neighbors. So yes, cardioid there is essential. Please note that the direct to reverberant ratio is raised. The exact value, in fact, is 4.7 dB by being cardioid, which means that we're exciting the room 4.7 dB less than with an Omni subwoofer, right? And I did not develop that, but I mentioned earlier that when we move the subwoofers in the room, yes, the result depends on the location of the subwoofer. Okay, but without going deeper into that, gradient subwoofer, cardioid subwoofers are less sensitive to their location in the room. Okay, and finally, interference pattern in stereo design can be minimized by rotating subwoofers outwards, but Nicolas will develop that in the second part because I just slightly touched on it. Distance between subs and walls should not be less than 0.5 for proper front to rear energy. The question is very often raised: how far should be my subwoofers? How far should I be from a rear wall? The distance is more than 0.5 meter. Otherwise, you better go Omni, because you will not allow front to rear energy to be properly transferred. All right. So Nicolas,
so we have question. I guess you could have a look. So we have a question which is more related to perceptions. So this is a question from Jonathan's, yes, regarding what you feel when you try one cardioid setup compared to the other one, and maybe another one which is a little bit more technical from Birds. So could you first answer maybe the question from Jonathan? So what is the difference in terms of a feeling between this kind of cardioid setup?
So the question is about the difference in sound quality from cardioid to
sound.
Omni?
Yes.
Well, to be honest, by the end, when I look at the end result, the cardioid sound is going to be superior. It's going to be superior because I'm not sending low frequency into microphones. So the microphone pickup is better than if I was in Omni mode. Okay, so that's one thing. And second, when I am inside the venue, I'm not going to excite the room as well as when I'm in Omni mode. So that's the second reason for making the sound better. So I hardly see a case where the Omni in reality would sound better than the cardio.
And what about between passive and active cardio? Is there a difference? I think that's what Jonathan was asking.
Oh, between passive and active, yes, there is going to be a massive difference because I'm going to go to the limits of the passive sub extremely quickly. The efficiency, we don't have passive subs at NEXO, but there are some available on the market, and the efficiency is really extremely low. So you cannot use them to do rock and roll shows or to do EDM or to do these kind of events, clearly.
I guess the question,
yeah.
The question was also between NFR and cardio. So I think the answer is more or less in the question because you mentioned, Francois, that Endfire always give a proper summation in the front. So I guess that summation in the front is maybe more impressive in Endfire, but the rejection at the back is less compared to the Cardioid.
Is not as good, and the coverage, including the front coverage, is inconsistent.
Okay.
Right? Because if you look at the front coverage, it's extremely wide at very low frequency, and it narrows. So your sub coverage, okay, on axis, it's fine. You have plus 6 dB, but your sub coverage is in fact narrowing. So it's inconsistent coverage, which is why we did not implement that natively in our subwoofers.
One more question. Is it needed to add delays to tops if we're using cardio mode subs?
No, it's specific setups. So you don't have to, you just select, front and back cardioid, and you connect, and you don't have to put any delay. And in fact, the delays are locked. That is, you're not, when you're putting cardioid setups on the NX amps, you're not allowed to change front to rear settings.
Okay.
Ah, Sasha. Birds, no, there is a very strong separation inside the cavity of the RS18, invisible to low frequency. No, but it's airproof. What matters in that case, Bert, is that the air which acts as a spring inside the box does not communicate to the next cavity. So, of course, we must not have air leakage from front and back cavity, right? And yes, an 18mm plywood separating the cavities will not allow the air from one to go into the air of the other. And this is the important thing. All right. So I see 10 open questions.
We are more or less, the same question, but I think we already answered that. But to make sure that the people understand, a question that said between Endfire and Cardioid, is the impulse the same? We more or less answer the question by saying that impulse in case of, and if we can talk of impulse in case of low frequency, in case of Endfire, they arrive exactly on time at the front, and so all these questions related to time arrival keep the same answer. Yeah, they are on time in the front for Endfire, and this is the only benefits of this technology. Can we summarize like that?
Yeah, I'm fine with that, Nicolas.
Okay,
I'm fine with that. And to be very honest, I don't think it would be possible actually to hear any difference. Just so that you guys are all aware when you're talking about impulse response. At NEXO, we have the same phase, right? For all, we have linear phase for all our speakers. All our speakers, all our subwoofers have exactly the same phase response, right? We go FIR to answer your, because there are a couple of questions on FIR. We go FIR only from 300 Hertz, because if we were to use FIR at lower frequencies, this would increase the latency way too much. Okay, you would need tabs for eventually cycles which can be 20 or 30 milliseconds long. So that would be way too long in terms of latency. So we use FIR from 300 Hertz, and we use all-pass filters below 300 Hertz. So the subwoofers, our subwoofers, if you use an Omni mode or if you use a Cardioid mode, they will all have exactly the same phase response. Okay, so this is to answer on how different in sound. To be honest, I don't think you'll be capable to hear any difference in terms of sound if you just make an open air between a single Omni or two Omnis and two Cardioid. I don't think you will be capable to listen to any difference in sound quality. Okay. All right. All right. Sasha, can I use the STM in ground stacks? Just to confirm, I imagine that your question is about putting them one on top of the other instead of one side to side. And the answer is no, because the setups of STM are designed for the systems being placed one next to the other. So the traveling distance going up would be totally different than the traveling distance going this way. But anyway, I consider this as a requirement, and we definitely can consider eventually to implement that. So we will evaluate that. And I saw another question. Sorry. So up. There was a question again about the distance, right? But I think we've answered. Will be the distance in France be different between Cardio and Omni? I'm not sure about that question, Damir. It's probably about the spacing between the subs in Cardio and in Omni mode. Anyway, maybe Nicolas will, in the second part, cover some of these questions. Wow, many questions.
Yeah, many
questions. Nitesh, yes. I'm not very clear about this. The leveling difference on one-to-one need to be compensated? No. Yes, well, that is, need to be compensated. A one-to-one will produce less than the 2/1. So that's going to be maybe a 2 or 3 dB difference that, yes, you will need to compensate if you use combined, okay? And fire and gradient combined subwoofer be help.
Complicated.
You can try, but yeah. I wouldn't play with that. I wouldn't play with that. Yeah. So, Sasha, I have it. Wow, so many questions. I'm sorry, I'm doing my best. 15 open. So Nitesh, please try to be more precise, front versus back. I'm not very clear on what you mean there. I suggest we take a small, so done, answer live, done, okay. I suggest we take a small break, Nicolas?
Yeah, so maybe what we can do is, so do you want me to, just to summarize how to get this directional behavior in NS1, just to show the people what is the, where do you play inside the software, just to move from Omni to Cardio, or is it good for all the people who attend the training?
I suggest, so you want me to open NS1 for 2 seconds then?
I have something, so I have something ready. So if you want, I can just show where...
Oh, please go ahead.
Okay, so just to show you guys, I will share my Windows if I find it ready, yes. So do you see something on the screen? François, you see?
Yes, absolutely.
Okay, so guys, so depending of remember, so some of the subwoofer, for example, in the case of RS18, they can be Omni or Cardio. So it's just a matter of having the subwoofer inside the room, and then I will use my laser.
We can see your mouse, Nicolas.
Okay, very good. So it's just by changing these settings right in the room makes you the ability to change from Omni to Cardio. Okay, so let's look at the pattern, for example. Sorry, so I grab this speaker on the room. So this is the default, so this is Omni. And if we change it now to Cardio, Cardio left, then this is Cardio left. Okay, so RS18 is in that case. If we use S118, be careful, it's we have to combine now 1 or 2 subwoofer. So I will replace with S118. So we have, for example, 1 subs. So by default, this is Omni. And if I want to get it in Cardio, so we have different settings available here. So side to side with a ratio 1:1 or a ratio 1:2, and back to back. So if I take this one, for example, 1 back to front, and look at the coverage. Okay, then we see that we have these cardioid patterns.
This is the 45-degree
45
right?
degrees.
Offset. The
Yeah.
that we showed.
And the back-to-back is 0 degrees offsets. Maybe we have to mention also with the back-to-back that the frequency, crossover frequency is limited up to 60 compared to 85 with other method. And the last family of a subwoofer are the M-sub subwoofer. So if I replace this one with the M-sub 15, for example. So once again, you see that in that case, the setting is a little bit different because we have front and back. So if you remember what you explained, Francois, if we want to get the recommended ratio in that case, we have to get 2 front and 1 back. So I just have to reverse the last subwoofer. So let's do it first, Omni. So this is Omni. Okay, and then if I go Cardio, and we have a Cardio. Okay, so 3 different families and 3 different settings on VNS1.
This is great. Thank you, Nicolas.
Right, so let's go with the subwoofer design. So subwoofer design, once again, preliminary, we discussed about that just before, so this is very easy, but this is more or less a little bit of discussions. If we try to look at the time we spend on system design, most of the time we realize that we spend more time on designing the subwoofer than the main array. And the reason is this one is because no universal rules apply. Okay, this is always a case-to-case situation. This is why it's a little bit complicated. And in this case-to-case situation, there is no ideal situation. This is always a case where we have different options, and we have to explore these different options. And these options must always be explored within implementation constraints. So we need to take care of where I can put the subwoofer. Okay, as simple as that. From time to time, you will try to make a very nice NS1 with a very good coverage, and just realize when you're on site that it's absolutely impossible to implement. Okay, because you don't have the space. Let's say you want to fly the subwoofer, you don't have you have weight restrictions, so you can't, or footprint restrictions because of the light. So you need to take care of what you want to do and what you can do. Okay. Sub-design is not a matter of displaying nice color. Okay, so be careful, because this is a drawback that we have from time to time, is try to get the best coverage, or maybe the best mapping on the software simulation program. But a software simulation program cannot simulate everything. Okay, and there is something in the case of a subwoofer that a software cannot simulate, is what we call the low frequency impact. So low frequency impact is to be, is when you get the subwoofer in your chest like that. Okay. Some subwoofer setup are very good for that, and some other are less good. Okay, and typically this will not be displayed on the software simulation program. This is something that you feel. This is something which is based on your own experience, and something that you know when you play with the subs on sites, on the field. Okay, but you don't have any information on the software. And most of the time, what you will have to do is the good compromise between coverage, consistency, and low frequency impact. And I can add also another third things is the implementation constraints. Okay, so if you are not able to put the subwoofer as you decided, you need to deal with all these 3 parameters. So coverage, consistency, low frequency impact, implementation. Right, quickly, we talk about that. Subs is Omni by default. And if two subs are spaced of more than half a wavelength, then you will create interferences. Okay, we know that. Let's talk about directional fundamentals, directional patterns fundamentals. So if we try to create a vertical subarray, okay, so one subwoofer is omnidirectional, but if we try to increase the size of a subwoofer, and just by increasing, for example, the length and creating an array of subwoofer, so we can do, for example, a vertical array. So this is what you see on the left side. So we have 9 S118 on the single line. And on the left side, what you see is the top view. And on the right side, this is the cut view, the side view. So from the top, if you look at the line from the top, what you see is a point. Okay, so it's still omnidirectional. So on the horizontal plane, you will get this omnidirectional pattern. But if you go to vertical now, you see that you started creating a directivity. So we have a directivity in the vertical plane. Okay, this is what you see here. This directivity, once again, is very much related to wavelengths. Wavelength is the size of the sound. If the size of the sound is bigger than the source, then it keeps omni. Example on the left is 4S118 flown, and what I visualize is the coverage for frequency between 31 and 63 Hertz. And you see that it's not really directive, it keeps omnidirectionals because the size of the array is too small compared to the wavelengths. If I look on the other pictures now, and if I draw a line, not a draw, but if I create a line of 10 subwoofer, then the size now is bigger compared to the wavelengths, and I can start creating some directivity. So directivity depends on the size of the source regarding the wavelengths. So once again, I want to create directivity. So I want to get a bigger subs. So I do a vertical line. The main problem with vertical line is the space, because if you want to ground stack, first, it's impossible to ground stack 10 S118. I think even in Japan, they can't do that. But if you try to fly 10 S118, then flying 10 S118, maybe in a theater, you will not be able to get the space available because this is too long line compared to the maximum height of the truss. Maybe outdoor festival is possible, but indoor in a theater is not possible. So if you don't have the space to run vertical lines of subwoofer, then you can decide to run horizontal. Horizontal is interesting because most of the time we have a bigger space in the horizontal plane compared to the vertical, because the horizontal width is most of the time limited by the stage. Okay, so let's say that we have a stage of 15 meters width. If I create an horizontal array of S119, this is what I get. Extremely directive. Okay, so we create directivity on the horizontal plane, and it's still omnidirectional in the vertical plane. Okay, so this is the opposite. The main issue here is that I try to get the subs as close as possible. Okay, so I just fill the space, every space available, I put subwoofer. And if I look, you will see that if I want to fill 15 meters with S118, I need 25 subs. Okay, so 25 is big, is maybe sometimes too big, sometimes it's okay, depending of your budget, depending of your inventory, depending of the application. But 25 is a big number of subwoofer. But I can get exactly the same effect with less subs. So how it's possible to get less subwoofer, but keeping the same directivity? is just to create space between the subs, but the space cannot be more than half a wavelength. Okay, so this is what I did. I keep the same width, but there is half a wavelength for 85 crossover. So this is a distance between, this is a distance of 2 meters. So this is no more than half a wavelength. And you see that the directivity is exactly the same. The level is not the same. And you see here we have much more level with 25 subwoofer than this one, but we still absolutely get the same coverage pattern. Okay. So the idea when you want to run any sub arrangements and you want to create, for example, horizontal line, is to get the space between the subs that don't go over half a wavelength. But there is something that which is not that we cannot visualize in this drawing, is something that we call mutual coupling. So what is mutual coupling? This is an effect that happens where we have two drivers which are very close to each other. So when we have two drivers which are very close to each other, they help each other move in the air. So this is much more easier for them to move compared to if there was only one driver. Okay, and this is what we call mutual coupling. We used to say, remember, we used to say that if I have one speakers and put another speakers, there is 3 dB gain. But in the case of subwoofer, if they are very close to each other, this is not 3 dB gain, it goes to 6 dB. Okay, so it can go more than 3 dB. And this is due to mutual coupling. Okay, this is in acoustics, we talk about radiation impedance or mutual radiation impedance. In reality, for us, what is important is if I increase the space between the subs, then I will lose the coupling, and then the impact sensation can drop significantly. Okay, so as long as the subs are very close, you will get the subs on the chest. Okay, very impressive. But if you increase the space, you will lose this effect. Okay, so less impact sensation. Another topics before we move to different example. Remember, if I do the vertical line array, for example, I can decide to steer, to tilt the beam downwards. So we have two different ways of tilting the beam downwards. You can do it mechanically, physically, but to be honest, tilting a straight line of subwoofer with mechanics is quite impossible because there are so many forces applied to the array that it's not a good it's not a very good idea. But you can do the same with electronics. So applying delays regularly from the top to the bottom can steer the line to down tilt value. Okay, so you can tilt the beam width on the ground. Remember that once again, changing time change phase relation, and if you change the phase relation between the subs, then you will be able to rotate the main lobes. But this phase change is much more effective for high frequency compared to low frequency. So for example, if I try to do electronic steering of 20 degrees at 31 Hertz, and you see that it's not really efficient. But if I keep the same settings and look at 100 Hertz, but you see that it's much more efficient. Okay, I will go back with this the story of steering alive with delays, because this is very appealing because just by playing with electronics, you can rotate the shape and you can rotate the beam width. But this has also consequence on the impacts of your subwoofer. Okay, I will discuss of that later. Right, so to summarize, the bigger is your source related to wavelengths, the greater is your directivity control. To make the source bigger, you create space between the subs, but keep in mind that if you increase the space between the subs, you must always keep no more than alpha wavelengths. In other words, this is 2.8 meters for 60 Hertz, 2 meters for 85 Hertz, 1.4 meters for 120 Hertz. Okay. But not talking about frequency, not talking about interferences. So apart from interferences, every time you increase the distance between the subs, you will decrease the coupling, and then you will have less efficiency regarding the impact. Okay, so less impact. Right. Setting up subs. So we'll try to have different looks at two different configurations. We'll start with a mono subwoofer configuration, and then we'll move to a stereo subwoofer configuration. So let's start with mono. What I can do is here. So what you see here is the NEXO field. So for people who already came to NEXO, this is the NEXO field. And what you can see here is the coverage of 6 S118. Okay, so we just put a bunch of S118 in the middle, and we put a pack of S118, and we see the coverage. So we start to creating a bigger source, but it's not as big just to get a very high directivity. So what we see here is more or less omnidirectional. Okay, a little bit directive, but not really omnidirectional. Okay, a little bit omnidirectional, sorry. What happened now if I change the shape? So this is an important phenomenon. If I change the shape of the arrangement and trying to make, for example, a curved arrangement, then you see that the coverage is wider. Okay, and once again, I go from here to here. So you see that just by changing the shape of the arrangement, I can increase the horizontal coverage of my subwoofer. Okay, so this is one possibility. But the other possibility, remember, if we want to get directivity, is to make the source bigger. So in that example, what I did is just to have a space of 1/4 of wavelengths between the subwoofer. And you see that compared to this one, sorry, so this one is no distance. If I go to this one, then I start to be directive. If I increase and go to alpha wavelengths, I will be very directive. Okay. In that case, to be honest, this is too much directivity. Why? Very good for the people who are standing right in the middle of the array, but for people who are on the side, they see a lot of subwoofer, but they don't have any subwoofer. They cannot hear any subwoofer because it's too much directive. Okay. So what we see here is the near field of the subwoofer. So in the near field, this is more or less consistent, but it's only a few meters from the stage. And in the far field, this is highly directive. Okay, not very good. So what is the solution? We can try to get a wider coverage by doing an arc. So if I do a physical arc, I will make a wider coverage in the horizontal plane. Okay. So the advantage of this solution is that this is very cost effective because I don't have to add electronics, or this is the array and I just have to rotate and create a shape with the subwoofer. The drawback is that you need to push the subwoofer. Sometimes it's not so easy. And the other drawbacks is you need space. Okay, because if you create an arc, then you need to get the space available. And maybe you will not be able to have the space available. And there is another drawback, is by doing this arc, you will create a focal point just at the back of the array. Okay, so there is a very hot point. Most of the time, if we run, for example, the music, it could be the position of a singer, of a lead singer. So maybe too much low frequency at that position and not very comfortable. So instead of doing a physical arc, I can do exactly the same with electronics. So what you see here is the delays that we applied from the center of the array up to the left and the right. So we have 0 milliseconds from the first subwoofer, then we go to 1.5 milliseconds, then we move to 4.37. So we just try to make the arc with the electronics. So when you do the arc with the electronics, then you can see that you can make this coverage more consistent. So we have a wider coverage. This is less directive, so this is better. We also remove the focal point on the back, okay, which is great. So these are all very good advantages. But the drawback is that you increase the space and then you increase delays. So the phase relationship and the coupling between the subwoofer are not very good. And that leads to impact sensation, which is not very effective. So to be honest, is the target of a subwoofer design is to have this impact sensation. This is not the best solution for that. Okay, very good for consistency of a coverage, but not very good for impact. So let's put that into practice, guys, with NS1, so that you can see how you can do it by yourself. So I will go back to my Windows. So this was the previous design. So I will remove PRS18. I will make a bigger surface also. Let's go 40 meters depth. And let's go 25 for the width. Okay, so this is the value. And I will also play with the M sub 18, for example, and you see that M sub 18, when I drag and drop these subs, I play with a stack vertically originally, but there is another option which is called stacked horizontally. So when you play with stacked horizontally, then you will access to another menu where you can design your cluster and your array in the horizontal plane. So how can we play with that? If I look on the left side, I can see that I can choose the quantity units. So currently I have 4. I can use more if I want. I can use 8. And you see that increasing the value make the space between the subs smaller. The reasons is why I specify the array size with a length of 10 meters. So I fix the length of the array size of 10 meters. If I want to get a bigger size, for example, I can change the value here. Okay, let's go 12, for example. If I go 12, you see that I increase the size between the subs. Okay, so I have a bigger space. And eventually, for example, if I decide to get a length of a cluster which is exactly the length of a stage, I can say that my stage is 15. Okay, and let's have a look of the coverage with 15. Okay, so this is the calculation at 80 Hz. So this is highly directive. I'm not sure that having 8 cluster that fill a 15 meters stage keeps the half wavelength criteria effective or not. So I can also visualize and look at what is the difference and the distance between center to center. So you see in that case that the center to center position is 2 meters. Okay, if the crossover is 85, let's go 85, then it means that the wavelength is 4 meters. So alpha wavelength is 2 meters. So I'm a little bit too much of distance. So if I want to get something which is better, I should decrease the distance between my subs. And for example, let's go 1.5. So I go 1.5. run calculation. Okay, and you see that it's more consistent, so this is better. And if it's not enough, because in that case, you see that this is not 15 meters, it's 10.5 meters, I can increase the number of subs, okay, and go to 10, for example. Okay, center to centers, I go 1.5, and array length now is 13.5. So this is highly directive, as you see, and I can create. I can make this directivity a wider directivity. So I will do a beam width. You see, I can change the beam width. So if I go, for example, I want a beam width of 60 degrees. If I go to 60, then you see that instantly you see the delays that apply on the array. And if you look at the results, this is now how is your coverage. So this is 80 Hertz. Let's go to 50. And let's have a look to the low frequency range. Okay, so this is what you get with 60 degrees of beam width, 0. This is directive. Okay. There is also what we call beam steering. So I can decide to steer one array on one side or the other. So this is exactly what we discussed before. If I want to do a 45 degrees series on the left, I play 55, 45, and this is the different delay. So to be honest, I will never do these things on a real situation. Look at the value of the delay, 27 milliseconds of delay for the subs number 10. So I'll let you imagine what is the phase relationship between this one and this one. So this is a typical example where you see nice colors on the NS1, but in reality, on the field, this doesn't sound very good. Okay, so I cannot go up to 45 degrees. So in reality, what we recommend at NEXO is try to avoid a maximum delay of 5 milliseconds. Okay, for example, you see the maximum delay is 5 milliseconds. I will not try to go more than that. Otherwise, I will really lose a lot of impacts. Okay, so if I go, for example, 80, you see 80 degrees. This value they are too big. Okay, so when you're happy with that, you validate, and you can visualize on your venue. This will be exactly the same. Okay, makes sense? Let's carry on, guys. So this was the mono. And now I'm going to play stereo. We talked about that. So sorry. So just to finish. So this is what I told you before. So increasing the distance leads to less impact, and steering the line increase horizontal coverage, but decrease also axis efficiency. That leads to less impact. So be very careful. And this is what we recommend. And this one is important. We recommend 5 milliseconds as a maximum delay value for the steer line configuration. Okay, let's move to stereo now. As you may know, when you run stereo, you increase the space between the subs. This is more than half a wavelength because you have one cluster on the left, the other one on the right. So what you create is interferences. And this is the typical coverage that you have when you run stereo is what we call power Haley effect. Okay, so very big summation in the middle. Then we have cancellation on the side, and then we keep to have a good summation on that side. Okay, to be honest, there are many cases where we don't have more choice than running a stereo because we don't have the space to run a monoline, and the only possibility is to run stereo. We can make this power Haley a little bit less just by trying to minimize the overlap zone right in the middle. So I try to minimize the overlap from the left and the right in the middle. So how can I do that? is just to make that my subwoofer cardioid and to shift the axis of the cardio outside. Okay, so if I have, for example, cardio right, which is shifted by 45 degrees on the right, and cardio left that is shifted 45 degrees on the left, then I will minimize the overlap zone right in the middle. And this is what you get. Okay, you see, by running cardio, so the good point is that you have a good rejection at the back, but there is also less differences in the area. You will still get the power ILA, but with less differences between the summation and the cancellation. So we used to recommend to the people, if they have to play stereo, in that case, maybe running cardio is a good solution. We can do also the same by steering the line. So you see the difference between the left and the right is that we create an horizontal array of subwoofer, and then we are doing an horizontal steering on one side. Okay, this is to exactly to this situation. So we do a steering on the horizontal plane. So this is another possibility. And if we compare now a stack solution to a flown solution, we will keep the power ILA effect, but flown configuration will always give more consistent coverage. The reason is that there is less differences between the first row and the back row of the audience. So you see, when the clusters are stacked, this is very, very high SPL in the front of the subwoofer. To be honest, in France now, this is not more allowed because we need to keep a value which does not exceed 180 dB C. And so when you run flown, you will see more consistency from the back of the audience and the front of the audience. And the other benefits is also, with a flown system, you will avoid the absorptions by the crowd, absorption by the people, which is not the case where it's stacked. So when possible, we also recommend, when you run stereo, to fly subs instead of during run stack. This is better. Of course, if you fly, you can also steer. Okay, you see the difference on the left. We have no steering, and on the right, we have vertical steering, and then we bring back the energy in the middle. Okay. Okay, let's have a look now to difference between Omni and Cardio. So this is a flown subwoofer. So we have flown Omni, flown Cardio. Once again, this is more consistent in the front. You can see the very good rejection at the back. And just for example, by running, this example is a side-by-side S119 with 45 degrees outside. Then you see that it's quite better also to minimize the zones for the interferences. Okay, it's better. It's much more better. Right. So we discuss about arrangements. Just before we finish, maybe some different things about crossover frequency. So as you may know, you can in the NEXO system, you can choose between different crossover frequency. We have most of the time 60 Hz, 85, 120. Could be more. In the case of M sub range, we have also 95, 75 available. And the thing is that you can choose your crossover, and the choice of a crossover most of the time is dictated by your own feeling and the application. You can create a perfect crossover between main and subs, and you can also create overlaps between main and subs. In that case, you will create like a boost in the low ends, depending on what you want to need. But what you need to keep in mind is the choice of a crossover is also related to the headroom. And for example, if you run a subwoofer at 60 Hz of crossover, you will have more low frequency headrooms compared to 85. Okay, so we need to keep that in mind when you choose a crossover. But also, crossover is dictated by the subwoofer arrangement and positions. Okay, In that example, we have a main system and two different subwoofer configuration. We have a mono stack configuration, and we have a stereo flown. And if you look at these two configurations, you can see that the stereo is much more closer to the main compared to the mono. And once again, remember when the distance between systems are very close, then having a crossover, a higher crossover is more effective. Okay. So in that case, regarding of your subwoofer arrangement, if you run a mono or a stereo flown, what we recommend is to cross over at 60 Hertz for a mono stack subwoofer, because this is a bigger distance, so the wavelengths are bigger, so this is better for the time alignment. And if you run the flown subwoofer, then the distance is smaller, so you can go with a higher crossover frequency, go to 85, and time alignment also will be easy to operate in that case. Right, so this was just a small conclusion regarding, position, subs, and crossover. So it's not matter of, explaining too many things regarding system tuning and system measurement. There will be a system tuning measurement session in a couple of weeks. So if you're interested, you can register to that session. I think it's the time for me just to go to this one. Thank you very much. And maybe to look at the question if you have question.
We have a question about what is the best cancellation when we do an horizontal subarray?
Okay, so the question is, if you want to have a very good cancellation at the rear setup, you can also run horizontal array cardio. Okay, so you have one horizontal line front. If you run back to back, for example, you can do one front which is for the front and the other one which is for the back. So having a cardio and running the horizontal array are independent, okay, and you can do both at the same time. Peut-on imaginer qu'on pensait une installation en arc inversé par l'électronique? Bertrand, est-ce que tu comprends la question l'arc inversé? Nicolas, can you precise? What do you mean by inverse arc?
Tant qu'on reste dans des valeurs de délai inférieures à 5 millisecondes, on peut essayer. On peut essayer. Il faut le tenter. Il faut le tenter. Le truc, c'est qu'on va perdre une bonne partie du délai disponible pour remettre la ligne déjà à plat.
Ouais.
Et le peu de distance qui nous restera, la distance à parcourir pour les remettre en arrière, va nous demander, à mon avis, trop de délai. Il faut essayer. Tant qu'on reste à l'intérieur des 5 millisecondes maximum entre les subs extérieurs et les subs du centre, ça peut se tenter, oui, bien sûr.
Donc effectivement, je viens de comprendre la question. Donc là, so the question, are we going in English? So the question that we have for French people is due to physical constraints. Sometimes you create an inverse arc. So it's just like comment dire, un fer à cheval, horse. Joe, comment
horseshoe.
Horseshoe. So it's just like the horseshoe, and the horseshoe is because of the constraints, of a limitation. And what we want to get is we want to get rid of this horseshoe, because when you do horseshoe, you create a focal point right in the middle of the audience, and you want to avoid that. So having delays just to compensate for this physical distance will be done just to get something normal, okay? And the answers from Bertrand was to say, as long as you don't go over 5 milliseconds, you can try to do it, because otherwise, if you do more, then once again, the phase relation between the middle of the subs and the outer of the subs could be very strange, and this will give you a very strange sound, maybe. is it time to say goodbye? I think so. Maybe two things. So I will thank you, all of you guys, just for being the panelists. There is another questionnaire that I will launch now, but you can answer. So I will keep the webinar open, so you can take your time to answer. This is a satisfaction questionnaire, just to help us to improve our webinars. So I will launch it now, and you can answer, take your time to answer when you want. And I will take the opportunity to say bye-bye to everybody. Thank you, Bertrand.
You're welcome.
For translation, but anyway, we'll try to see what we can do later. Thank you, Joe.
Thank you, Nicolas.
Thank you, Reinhard. Unmute. And so I will keep the webinar open.
Nicolas, if anybody has any questions, where can they email NEXO?
Yeah, you're right. Thank you very much, Joe. So for any question, there is always email which is open 24 hours. Should I say 7 days? Maybe not, but maybe. This is a technical at NEXO. I will write on the...
C'est fait.
C'est fait? Oh, thank you.
C'est fait, je l'ai mis dans le,
Super, merci.
dans le chat et dans le Q&A.
So technical at NEXO, you ask any question, and we very pleased to answer. Thank you again, everybody. See you next time.
Thank you, Nicolas.
Bye bye.
Thank you.
Bye bye.